Hi everyone. This lecture is a revision, okay, uh, regarding last time lecture about the derivative. Such that this derivative is following the slope of tangent line, though we already studied too much about it, but this final revision is required to understand its key concept. So, as we already familiar or studied this concept that 1 over x derivative of this equivalent to 1 this expression. Similarly, we already gone through the rate of change of xn equal to sum of n x n minus 1, where you can say that n equivalent to 1, 2, 3, so on. Okay, today I want to finish up, or you can say I want to talk about that what is derivative. Until we studied a lot about slope of normal equation, slope of tangent line. So and we concluded that slope of tangent line leading toward the derivative. But what is derivative? The question is though pretty simple, and though it is not a new thing, but continuation of the last lecture that is also telling us about the rate of change, okay, at some instant or some particular position. So this position can be, okay, usually sometimes people are considering line touches the curve at one point, that is known as slope of tangent line, or it's a derivative. Some people are generating the function like this or like this. So it doesn't matter, okay, if you considering the function like this, it's a curve, and you say that in some plane. So okay, we can say that along x-axis this can be delta x, along y-axis it can be delta y, so it's the average change. So from this point to this point it is kind of a slope of normal equation, or we can write this in the rise over run form like this. So it is telling us average rate of change, or you can say the slope of normal line. So but what we are considering this concept delta y or delta x approaches to small, okay, this information at an instant. Once delta x approaches to 0, okay, this slope of normal line will be changed into the slope of tangent line. So this is the derivative, and if we see the examples of this concept, it is each and every nook and corner of our life follow the concept of a derivative. So for a moment let me say some charge, okay, example of this is a charge, electric charge, you can say, and once we want to determine the charge, we can say the rate of change, and this one it is known as a current. Similarly, if we say some another simple and very typical thing, distance, and this distance once at an instant it will become speed. Okay, very typical example. Let me explain this simple and typical example for for understanding the concept of derivative. So consider, okay, for illustration purpose, some students are, we are at, okay, first floor, some students are, okay, let's suppose an example of a ball drop. So you should remember this theme. Ball drop is following the concept of derivative. Suppose the height of this first floor from the ground, okay, some students, okay, want to drop a ball from the first floor. They are standing somewhere there, okay. So once they are throwing a ball, and of course ball will okay, fall on the ground. You can say that there is some grass, okay. So it follow due to effect of gravity, okay, they are throwing ball like this. So the height, okay, of this building, suppose it's 80 meter height of this building. And okay, if I consider some equation of motion, okay, Newton law of motion, we familiar, okay, this is the concept with respect to height. I want to say, suppose this one is some assumption. I'll discuss it during the discussion portion of a class, why I am choosing it, though it's following the Newton equation of motion. So this is basically this one is a concept of acceleration of gravity. So we can say that we need to go through our basic physics. So at once ball is in hand of a boy or a student at time, okay, let me go to, at time 0 at the first floor, height is kind of 80 meter, and of once okay, ball covers some distance, okay, suppose boy student leave the ball, then after time of 4 seconds, then height will become 0. So at that moment ball will touch the ground. So ball will touch the ground at this point once after at time 4 seconds. Okay. So this one is the given information or calculated information. So there are two things. First thing, these following, suppose this one is the initial, okay, reverse order, you can say that fixed point or at the point of origin, we or other vice versa, we can say this one is the y2 height, okay. Let me talk about this. This is the y2, this one, and this one is the y1. Similarly, we can say that this one is the time t2 final, and this one is the time, okay, initial. So for general equation of, okay, so in this situation we can say that rise or run of height with respect to time is kind of we can say 0 minus 80 meter and 4 second minus 0 second. So we will have, okay, this average rate of speed. Now we will check out the average speed, okay. We will see what's the difference between average speed and instantaneous speed. Okay, instantaneous speed is the speed which we want to know when ball will hit the ground at this point. At this point, what's the speed of a ball? Okay, we will calculate, or even it is possible to determine the speed somewhere in mid, okay, at midpoint, this point, of course speed will differ, but we want right now in simplicity case, we want to check out the speed at an instant when ball will touch the ground at time t equal to 4 seconds. Okay, so this is the average speed at this moment. We can say it's the minus 20 meter per second. Minus sign is representing, okay, you can say that acceleration is decreasing or some change is So height is decreasing, okay, so there is a negative sign. Height is decreasing, so negative sign. So let's, okay, it's a speed. Let's check out that how we can determine the instantaneous speed. So again to the basic equation of this one, this, okay, take the derivative of this equation, then we can see dh or dt. So the first one, this is a constant thing, okay, 80 meter. If we are taking the derivative of constant value, it will, answer is 0. Why 0? Because we have too many, okay, here we have value of n order 1, 2, 3, but one, there is no order, no variable, okay, no variable is involved. Then it's a constant. Constant means there is, before 1 there is a 0. So wherever there is no variable involved, then we can say there is change, no change. Basically, in our early classes, teacher told us that derivative of constant is always 0. Basically, once someone is died, okay, static, there is no movement in a body, then is there any change will happen? No change will happen. Once there is no change will happen in the system, then of course change is 0. So derivative is name of change. There is no change, then derivative of constant means static, is equivalent to 0. So let's see the concept that 80 meters is a constant thing and it will become 0. So here is a 0, and for the other part, minus 5t square, of course it will follow the concept of derivative, so it will become minus 10t. Now we will have this value minus 10, and here we need to substitute the value of a time t at, that is, okay, we want to know the height, okay, speed at time 4 seconds, 1t is 4, so we need to substitute here, then we will get answer 40 meter per second. So speed, okay, speed is, you can say that this is the prime, h prime is the speed at an instant, 1t equal to 4 at time 4 seconds, but this one is the average speed, so it is minus 20 meter per second, the other is the minus 40, okay, minus 40 meter per second. So it's very simple, we can see the difference between two speed. Average is minus 20 meter per second, whereas the instant, once the ball is hitting the ground, it is equivalent to, okay, you can say double of the this average speed, that is minus 40 meter per second. So our instantaneous, you can say, information is, it might possible too much differ from the average information. All this concept was relating to this phenomena. So similarly, we can see a little bit more about other concept of a life. For example, temperature is representing with T, and once we are taking the gradient of temperature, or taking the, okay, there is a word gradient. Gradient is also using for representing a derivative. So with respect to time, temperature, okay, from cold to hot or hot to cold, can be observed at particular instant. What's we are checking our calculator or checking our mobile phone, there what's the weather today, and at that in the evening what's the temperature outside. So this is also the rate of change of weather. So we can say sensitivity, okay, sensitive, or you can say sensitivity measurement. Sensitivity of measurements can be done with the help of derivative. Remember this. Whenever sensitive issue, or we want to check out some murder, time of a murder. You can say there is some body which has happened murder at midnight. We want to locate or we want to know at what time this murder is happened. So with the help of derivative, we can know this information. Moreover, for landing of aircraft, for example, we can say GPS system, global positioning system, also following the concept of derivative. So suppose aircraft is landing, or there is some satellite GPS around the globe, or some where it is telling to aircraft, first, for example, at some position there is a runway. It is a runway, and this line is representing the distance from GPS to runway. But aircraft do not get the mobile information or mobile signals. So at in aircraft is following the GPS global positioning system, and it is impossible for aircraft to exactly locate the distance, horizontal distance. Suppose this distance is L. It is not possible for aircraft to determine this distance, but aircraft is observing this information as, and of course there is a ratio, as I told you people in early days, that there is a ratio of this, because for landing purpose aircraft must know about L, but there is a ratio. So this ratio is mirrored with this, but at once this one delta H approaches to 0, then this ratio will automatically be minimized at particular instant, and it will tell to pilot exact landing position with respect to height or with respect to certain GPS information at L is at the particular, even few meter or few you can say that meter can make a danger for the aircraft landing system. So almost the safe landing is possible, and the concept of ratio is following. For example, if there is a ratio of 12/2, or you can say that in case of double it can be so increase or decrease. So by approaching this delta H, once this delta H approaching to 0, then of course the aircraft is approaching its exact position of landing. Thank you so much.